mostly talking about English, but including Korean, there are so many languages, and then the amount of resources are varying. Of course, English is the most resource rich. They have the largest amount of corpus available, resources and everything, while Korean is considered to be medium resource. And then there are very low resource languages where there is not much corpus, or so for example, for Korean there are good like post-tagger, tokenizer, and so on, but those tools may not be available for some language. And then people are also interested in very extreme condition where you have zero information about the language. When disaster happens and you have no tool, no translator in that country, can we do something in zero shot? So those are all very important questions. And so far our discussion has been focusing too much on English. And why do we care so much about cross-lingual NLP? This is MAP. And well, for example, if you're English speaking, when you're hungry in this city, and if your MAP language option is English, there are so many restaurant information, but if it is in Korean or other language, you may see only 2 restaurants or none. And what we want to do is making sure in Korean map and in any language that you speak, the same amount of resources is available, but then if you think of it, it is not that easy. Well, this is named entity, so it is very difficult to translate. Well, of course we can transliterate, which means we just write down in Korean as it sounds. Steak and Korean house Zagreb. We can of course do that, but the proper translation is difficult because for generic word there is dictionary and other resources, but it is non-trivial how to translate like movie title, music name properly in another language. But we are hoping that what that suggests is that depending on which language is your native tongue, the amount of resource and amount of tools available can be very, very too much, which can affect like daily life decisions. So we are interested in transferring as much from resource rich to another language, which is the target of cross-lingual NLP. And I think it is a very interesting, very interesting research direction, and also it is in a way related to multimodal. I know that some of you, your main research topic is vision, and then you talk a lot about multimodal language model. And then the key idea is alignment. So what we want to do is that, let's say we have word to back in English and word to back in French. What we want to do is that we want to be able to align the 2 space. So if you can align cat with sha and dog with chin very well, then we can mathematically translate a word from English to another. So let's say we have dictionary of these 2 pairs, and then if we somehow can, and we have word to back for English and word to back for French, which can be obtained without any supervision. If you only have English corpus and French corpus, you can have word to back on their own. And we may have dictionary, very tiny dictionary of 2 pairs, and then we can use that to align these 2 the best we can, and then rest of it could be mathematically determined. So for example, car, we can come up with some translation function f from cat to sha, and then we can apply that and then try to find the nearest neighbor in French space. And we can imagine a space of English word and the image of cat, and we can try to align cat with cat image and sha with cat image. And then this alignment can be even richer because regardless of the language, this is cat. So that's the power of multimodal model, because they have this grounding in addition to dictionary, that cat and shall will be translation pair if they refer to the same image. And then we can extend it so that we can learn how to align English sentence with the French sentence of the same meaning. If we know this alignment, that means we have translator. If we have this function f, we can apply that function f to some unseen English text, and then it will be close to the French sentence. We can decode that vector, and it will create this French translation. And so this English word and image can be extended with caption sentence, long sentence with the image, and then it could be extended for long context, English document to French document. So we want to know how to align them, and then that will solve a lot of problems. That is the solution for a lot of problems, like translation, summarization, and a lot of problems. So we want some cross-lingual word embedding. Okay, we may have some bilingual supervision, or we may not have bilingual supervision. So we'll take a look at those cases. So this is mathematical view of what I just said. We have two languages, English, and then I think this is German. This is source, and then this is target. And then this, you can think of it as a word-to-vec in English, and this is sort of word-to-vec in French. They are separately trained, but then we can try to learn some projection metrics which can be multiplied to source to be as close as target, so we can optimize for mean square error versus projected from source versus the real target projection. And there are lots of, you can imagine lots of different distance metrics to optimize for this task. Okay, so mathematically this is what we want from source language vector space. We want to multiply